So in this video, we're going to work a little bit with the limits of functions using the limit rules that we reviewed in a previous video. And if you've skipped that video, please check it out. It's in the same playlist. And we are going to look at examples that can be difficult because they include several issues. So our main example in this video will have a square root in it, and you'll see in a moment what the problems are. So f of x equals square root of x squared plus 25 minus 5 divide by x squared. So that is the first function we're going to look at, and then we're going to look at a variation of this. What are the issues with this function? Well, if we want to look at the limit x goes to 0, well, first of all, we have a problem with the square root, which we'll get over by using our rules of limits. But mainly, we have a problem that we're dividing by 0. And division by 0 is, of course, illegal. It's not okay. So we're going to have to look for a way around this, because we won't be able to just substitute x equals 0 and see what we get. If we substitute, we're going to get f of 0 goes to infinity because we have division by 0. So this is our main problem here. And to get over that, we're going to use a little trick. And I'm going to show you this trick, and you'll see that it's useful in many other problems that you will encounter in your calculus classes. So what we're going to do here is we're going to try to get rid of the square root. That will be our first step. How do we get rid of the square root? Okay, so I'm going to write this down. How do we simplify the square root? Okay, well, there isn't a direct way, but what we can do is we're going to use something that we learned in algebra, and that is if we take a plus b in parentheses and multiply it by a minus b, what we get is, let's multiply every element. We get a squared, then we're going to get negative ab, then we get another positive ba, and then a negative b squared, right? Now, negative ab plus positive ba cancel because we have the commutative law, ab equals ba, and we're left with a squared minus b squared. Okay, now when we look back at what we have here, we have a square root term. And to simplify the square root, we really would like to square it. So how can we do that in this expression? Well, if we look here, we can say maybe our a is going to be square root of x squared plus 25, and our b is going to be 5. So here we have our f of x is just a minus b divided by x squared, right? According to these a and b's. So we would like to multiply our a plus minus b by a plus b, because then we know we're going to have that a squared. But we can't just multiply the numerator of this fraction by a plus b. We have to make sure that we're doing the same operation on the denominator, right? If we have a fraction p divided by q, if we multiply the top by a plus b, we also have to multiply the bottom by a plus b. That way we're guaranteeing that we're actually multiplying it just by the number 1, because a plus b divided by a plus b is just 1. So there's a couple of tricks here. One trick is we're going to multiply and divide this fraction by the same element, a plus b. How do we choose a plus b? Well, that's part of the other trick, and that is that we want to get to this expression here. So we're going to multiply and divide by the square root of x squared plus 25 plus 5. So we will multiply and divide by the same term, but we're going to do plus 5 because we already have the minus here. So after this whole explanation, I will do this more neatly now. So let's just move up here. So we have f of x equals the square root of x squared plus 25 minus 5 divide by x squared. And we're going to look at the limit x goes to 0. Okay, in order to do that, we are going to multiply and divide both elements of our fraction here. I'll write it out first. By the square root of x squared plus 25 plus 5 divided by x squared plus 25 plus 5. Again, we are multiplying and dividing by the same number, right? So we haven't really changed this fraction. And again, we're looking at the limit when x goes to 0. Okay, so what do we do now? Well, the whole point was to multiply this a minus b by this a plus b, right? So when we do this, we're going to get the limit when x goes to 0. And our top part is just going to be x squared plus 25 minus 25. Again, why is that? Because a minus b times a plus b equals a squared minus b squared. That's our top. Our bottom is not going to simplify. We have x squared times the square root of x squared plus 25 plus 5. A quick reminder, when we multiply two fractions, we multiply the two numerators and we multiply the two denominators, in case you've forgotten that. So that's just a side to remind you of how we multiply fractions. Okay, so we have this new function that we're looking now at the limit as we take x to 0. Now immediately we see that our 25 and negative 25 cancel each other, and we're left with the limit of x squared divided by x squared times the square root of x squared plus 25 plus 5. Okay, we also see that we have two similar terms in the denominator and the numerator. We have x squared. And so these two can cancel because we haven't yet taken the limit x equals 0. So we can now cancel these because x is small maybe. We're approaching 0, but it's not 0. So we cancel this and this x squared becomes 1. So now we're looking at the limit of x goes to 0 of 1 divided by square root of x squared plus 25 plus 5. Now we're getting to the point where we could use our limit laws. And the limit law was, right, that if we take the limit of f of x, we can also really be looking at the function of the limit of x, right? So we're going to do that twice, really. We're going to look at the limit. So we're looking at the limit x goes to 0 of 1 over square root x squared plus 25 plus 5. Now our first function is going to just be 1 over. Okay, we'll call this y. So y is the square root plus 5. So our first function is 1 over y. So this equals 1 over the limit of square root x squared plus 25 plus 5. we're going to take this same rule and apply it again, and we'll say that we're looking at 1 over the square root of the limit of x squared plus 25 plus 5, and this limit when x equals 0. Now, here we can take the limit x equals 0 because we have this 25 that will ensure that our function doesn't go to 0, that the whole denominator doesn't go to 0. So again, we can say this is equal to 1 over the square root of 0, the limit of x squared when x goes to 0, 0, plus 25 plus 5. And now we have just 1 over the square root of 25 plus 5. The square root of 25 is just 5, so we have 1 over 10. And so the limit of x goes to 0 of x squared, square root of x squared plus 25 minus 5 divided by x squared is equal to 1 over 10. And that is our result for the limit of this function. Now we're not going to end here. We're going to do this sort of again, but with a slightly different function, just for the practice. So let's look at the case limit x goes to 0, square root x squared plus 25. So it's the same numerator plus 5, but now in the denominator we have x. What happens when we do this? Well, similar to the previous time, we'll go through the steps more quickly now. I'm going to multiply and divide by the same factor. So we're going to take x squared plus 25 minus 5 and also divide by that factor so that we're multiplying, dividing by the same factor, so we're really essentially doing nothing to the actual value of this fraction. Okay, now again, because we have a plus b times a minus b, we can quickly go through this step as well. So we have x squared plus 25 minus 25. This time we're dividing by x times square root of x squared plus 25 minus 5. And again, the 25's cancel, but this time we are left with 1x in the numerator because we can cancel that second power with this first power here. So we have x squared plus 25, plus 25 here. That was my mistake, plus 5, not plus 25. Okay, so now what happens when we take x to 0? So now the limit has to apply both the top and the bottom of the of our fraction. And again, we have a rule for that. We can say that the limit of x equals 0, in this case, equals to the limit x goes to 0 of x divided by the limit x goes to 0 of square root x squared plus 25 plus 5. Now, we did the limit in the denominator in the previous example, so we know that that just equals the square root of 25, right? Here, basically x goes to 0. The square root of 25 is just 5, so we have 10. But on the top, the limit of x when x goes to 0 is just 0, right? And 0 divided by 10 is 0. So this case is a little bit different. We had a different power, and we can say that the limit of the square root of x squared plus 25 minus 5 divided by x, the limit of all this when x goes to 0 is equal to 0. And that is our final result for this example. So again, what we've done here is we took a relatively complicated function that had a square root and had division by what looked like 0 because we were taking x to 0. We simplified it using a couple of steps. Most importantly, we multiplied and divided by the same factor. so that we were basically multiplying by the number 1. We took advantage of the rule that a plus b times a minus b equals a squared minus b squared. And then we used the limit rules to go under the denominator, to go under the square root, and to take the limit inside of those functions because the limit exists. So I hope this video was helpful, and we'll have more videos discussing a few more rules of limits, specifically when they don't exist. So join me for the next video as well.